Hi folks, this is Alan Gabson Howell. We're talking about the SVR today. There's been a lot of controversy about this mod, and we're not going to do your typical review of the mod. Everybody's reviewed the mod, from my understanding, pretty much to their heart's content. So if you don't know that it's got 3-click and it's got little blue mode, ego compatibility mode, red, yellow, green for the different voltage levels, then you've been missing something out there. You need to check some other YouTube videos. What this is a video that's designed to show you what the SVR does with the voltage. And we've got a full carto right here, the carto that comes with the unit. We are set on high, red level, and what we're going to do is just let you know, small oscilloscope here, pocket oscilloscope. The oscilloscope is set for 2 volts per division, and the sweep is set for 10 microseconds per division. We've got this thing all zeroed out, and it's connected through this cable to the oscilloscope. So what we're going to do is hit the carto and let you see the voltage waveform as you hit the carto on high. There's no point in going through low, medium. The high is where I use it. The waveforms are not that different, but this will give you an idea when I take it another step what this is doing to produce the consistent hit that it produces, and then I'll explain how that happens. I'm not going to get too deep into the technicalities of it, although I would really love to, but enough to where you can get an idea of this is a little different mod than what you've seen before. So we're going to hit this on high, just and you can see the waveform is fairly stable. If I freeze the waveform for you, that's basically what you were looking at. That's on capture, and when I look at my voltage levels, I'm looking at 7.92 volts peak to peak waveform. I'm not even going to get into the frequency because the frequency varies quite a bit on this. This is not a stable frequency mod. You'll see that in just a moment here. Now we're going to unfreeze that. We're going to take a look at it on high again, but what we're going to do is we're going to slow down the sweep frequency. I know this is boring. Okay, we're going to slow down this sweep frequency so that that trace is moving across the screen at 1/2 second per division, 500 milliseconds per division. So this thing is going really, really slow, but it's going to allow you to see how this waveform changes when you hit the carto, and we're just going to go ahead and do that again. Probably better if I just go ahead and look at this and freeze the waveform for you, and then you can take a look at it. So I'm hitting it now. And it didn't freeze for me. Okay, that's frozen. I'll post pictures of this because I'm sure on camera you can't really see, but now you see this waveform, instead of being this square wave, an individual trace, we've got this wash of traces compressed, pushed together over time. Now what you're going to see is right here that voltage has dropped off, and over here the voltage peaks are squished together. So what you're really looking at is more of a frequency modulation of a fixed pulse width waveform. So what's that mean? Well, what this mod, if what I am told is correct about its operation, and I really have no way of determining that because that's engineering level data, But what I am told is that through a method called inferential analysis, this device is sensing the temperature of the coil itself, and it's adjusting the output voltage so that when you're not hitting the carto, that thing is not heating up as much, which is why you see these 0 voltage portions in here, and then back over here that compresses back together, and you get more voltage peaks within your half-second interval, and therefore more power delivered to the cartomizer. Now, how does something without a temperature sensor in it achieve this? Well, it's actually pretty simple. A piece of wire has a resistance, and that resistance, when you buy wire, that's specified at 68 degrees Fahrenheit. Most wires that you buy increase their resistance when they're heated up. But when you're hitting this guy here, you're heating it up. So when you take a resistance reading on a carto or an atomizer and you say, I've got 2.2 ohms, 2.6 ohms, and I'm using thus and such voltage, you're making a static calculation saying I'm getting so many watts out of it. Not true. When the coil heats up, the resistance goes up. In many cases, that resistance can double. When it's doubled, you basically have half of your calculation of power delivered to the cartomizer. So it's kind of a deceptive sort of calculation that you can make when you don't take into account that sort of effect. Now, this is feeding a certain amount of voltage, basically almost fixed, to the cartomizer. So the processor chip inside of this module here knows basically where the voltage is at. By looking at the current that's flowing through the coil, it can determine the resistance. That's a very simple calculation to make, and it can correlate that resistance to an assumed temperature. By increasing the voltage or increasing the frequency of the voltage applied to the cartomizer, it can deliver more power. By decreasing that frequency, it delivers less power. And by establishing a target resistance level, inferentially this means a certain temperature is going to be achieved. By establishing this target resistance level and maintaining that cartomizer coil at a certain level, you're regulating the temperature. That's how this device is different from Provari, Darwin, Buzz, any other mod out there that has variable voltage. Problem with variable voltage or regulated voltage, regulated power, regulated current, they all have the same problem. Even though you're feeding a fixed power, current, or voltage to that carto, you're always adding that. When you're always adding that power to the carto, that carto is always heating up. Same goes for an atty. It's continually heating. In this way, when you cut off the voltage, and you'll see that's cutting off the voltage, that's down to 0 volts. You are cutting off the power to the carto, you're allowing it to cool for a very small period of time, and then back to this variable frequency sort of paradigm here. So to call it a variable voltage is not really accurate. To call it temperature controlled, as rudimentary as this is going in the right direction. This sort of engineering is going to change vaping, or the way that you look at vaping. What you're going to want is something that maintains a constant temperature. You want a mod where you have a few buttons here, punch, 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 this is the temperature I want, this is what this juice bakes at best. Take a vape, no, too high, too low, adjust it, and this thing stays at a rock steady temperature. That's the whole idea behind the SVR. Now, recent controversy. SVR is surrounded by loads and loads of controversy. Is it exclusive? Who cares if it's from China? Everything you buy is from China anymore. So this is not really a big issue here. Is it exclusive to Axton Hughes? It may or may not be. Import rights on the SVR. Loon Totem will not deal with anybody except Axton Hughes on the SVR. Not a problem. We've dealt with that before. There are exclusive deals. So how do we know if this is a unique device? We take a look at the Evo. And yesterday I drove into Carson and I met a very nice young gentleman named John. And John is the owner-operator of 310 Vapors, and he was more than happy to sell me an Evo. And we don't need to go through the whole unboxing. It comes with a charger, USB cable. It comes with a single tank atty, which I have not tried. I am not going to try it. My opinion of tank addies is that they change the flavor too much for me. They may be perfect for you, but they change the flavor too much for me. So what do we, the big difference between externally, when you look at it, that looks like the same mod, except for this battery tube cover is something like about 3/8 of an inch too short. Okay, oopsie. Or does this go for a different model? I'm not certain. John says for $5 when they get the new ones in a few weeks. Of course, China is closed right now, as far as this business is concerned, for import, export, and manufacturing because of the new year. So he says people will be able to buy a new tube for $5. Not a big deal. His price is $69.95, I believe, or $69.99, and so you end up with 2 batteries, charger, tank addy, empty bottle, just like what you've seen on the SVR reviews that you may have seen. I have not watched any SVR reviews except for one on Facebook, and frankly I don't remember if that was Adam or Jimmy, but that's basically all I've seen. I have not seen Phil Basardo's production as much as I've wanted to see it, mainly to keep my opinions my own. Phil may have different opinions from mine, and I don't want to pollute what I'm going to tell you. So that's my part of credibility and ethics. What are the differences? Well, the depth of the addy connector is one difference right here. This little guy here, the SVR measures at a depth from the center pin to the top lip of this connector at 4.5 millimeters. I'm consulting my notes here. The Evo is 4.1 millimeters, 4.1 millimeters, so it's 0.4 millimeters shorter. I have seen comments about the problem with connecting certain cartos or addies. This may take care of it. As far as I'm aware, this is an older design. That the depth of this addy connector on the SVR was specified at the 510 standard. This industry needs standards just like any other industry needs standards. They basically call this a 510 5 1/10 turns. So that may be true, that may not be true. I am told that there is another standard out there or that has been developed or has just accidentally occurred, basically has become a de facto, that's 3.1 turns to put your addy or your carto onto the top of a mod. That may or may not be, but a lot of people talk about that, so I've used that terminology in trying to explain that the Joy standard was used here, and this other standard here may be a domestic standard. It may not even be a standard at all. Who knows? We're not going to get all involved with that. If the SVR causes you a problem with this, the fix is so easy, it's ridiculous. You go to Mad Vapes and you pick up one of these little 6mm extenders, and you cut that sucker down to, I think it's about 4.5mm, something like that, and that's what you do. You screw that guy in the top, and whatever you want to attach to that will not touch the center connector, you screw it on top of a filed off connector. Eventually somebody will say, gee, you know, let's go ahead and make these as some sort of connector adapter, connector standard adapter, whatever. It's too easy to make. You buy one, you take it out to the grinding wheel, you knock it off, you hit it with a file, sandpaper, anything else, you knock off a few millimeters, you're good to go. Not worth fussing about, and it shouldn't stop you from using your favorite atty or carto on the SVR or any other mod where this is a problem. Now, back to the Evo. It has the same modes. It has your Eagle compatibility mode. It has red, green, yellow. They all basically meter out the same way that the SVR does. But those sorts of things really don't tell you an awful lot. So we're going to look at that on the scope. And the thing that I am most interested in at this point in time is, does this device function the same way that the SVR does? We don't know, but we're going to find out. This is set for high, just like the other one was, and we still have a captured scope waveform right here, which right in front of you I'm going to uncapture that and put this back on scan, and you'll see this this little blank spot in the baseline scanning across. This is the rescan on this. So if we hit this and this darn thing is designed the same way, we should see a similar waveform appear here. And if we do, this is going to tell us that the Evo and the SVR, if not identical in design, at least achieve the same function. That functionally speaking, there's no difference between the two. If you're a price shopper, grab your cheapest price and you're good to go. So let's take a look. Let's see, where are we at here? The darn thing went into cutoff on me, but would you looky there? Lots of vapor. And that carto is fantastic, by the way. I hate cartos, and I love that carto. So first rate carto. Right here in the waveform, you can see the spreading out and dropping out of these peaks. They're closer together over here, and they're closer together over here, but they're further apart back here. Well, this tells me that the Evo is doing temperature regulation just like, let's do it again. I want to cook something here, I guess. Shorted out the carto, possibly. I don't know. Batteries. These batteries are probably very well used. So we'll cheat and use the ones from the SVR. And that's the 3.7 volt battery. Give them a try. By the way, the sales spiel, yeah, I just killed batteries here. The sales spiel on the, and I've also got the SVR top here. There we go. Now we're back on Evo. Okay. All right, after much ado, here we go. We'll go back around again on this. Now we've got it back on high. Now, if you noticed, I was puffing on this thing, and the response, there's a certain amount of lag time on this response too. There's got to be, because you have thermal inertia and the coil in the carto, and so you're always going to be lagging behind the temperature changes just a little bit. Again, this is the first mod that's come out with anything like this, and you can still see right here that the voltage is changing, or at least the frequency of the voltage is changing. Back down here we have a spread out pattern with a point where this is, the voltage is always on, and you have a repeat of that right back over here. And I find that very interesting, because this is identical. In order to get all of the patterns out of this thing, you've got to sit here with the scope and do it over and over and over again. But this is typical of the patterns that I've seen from the SVR. So the conclusion, and I'll go ahead and save this. I'll go ahead and save this file here, and that'll be posted as S022 image file. So S022 will be the image file for what you just saw me produce. This saves it on a little SD card. Is cool. Nice for a very portable pocket scope. Extremely accurate within the limits of a device like this. You can buy devices that are a couple of $1,000s, big bench scopes that really don't do a whole lot more than this one does when you get down to things like this. I've tested this out. Its accuracy is very good. So, at any rate, this waveform leads me to conclude that without tearing apart the module, which I may or may not do to take a look at the circuit board, this leads me to believe that the engineering that went into this is identical to the engineering of the SVR. So we can say that there is no difference effectively between the two, except for the shorter cover tube. That one right there. That guy's too short. If you want it as a cover, it ain't going to do it. It's great for carto cover, but if you're going to lose this thing, you'll have to pocket it. That's kind of a pain in the butt if you like convenience. I've got spare covers here, so it doesn't bug me all that much. The depth of the atty well. This one here will allow more atties to be used than the SVR will. So that's your call. If you bought an SVR and this really bugs you, make yourself a little adapter, or if you're really just kind of, I don't want to deal with adapters, you take a file, you file the top of the thing down until your atty fits. Not a problem. I shouldn't have to do that. I agree with you. You shouldn't have to do that. But it depends on what you buy the thing for. Now, on the website where the Evo is sold, there is some text there that says, unlike similar models, which implies the SVR or the Evo that's being sold. This is the 3VO. Unlike similar models, there are not problems with the battery tube fitting batteries. These guys go in great, and you can say fits perfect, whatever. You can use AW16340s in this. This is what John had on his model. I saw them come out of the battery tube. They work. I have nothing more to say about it than that. However, the battery tube on the SVR, is it different? Yes, it's different. What is the difference? I'll consult my notes here. Battery tube inside diameter, that's the diameter the battery's got to fit into. That's the part that really matters. This is 16.71 millimeters in diameter, inside diameter, for the SVR. For the Evo, that calipers out at 16.56, or the 3V rather. So if anything, this is 0.2 of a millimeter, a little under 0.2 of a millimeter narrower. So if you're going to have battery problems, you're going to have problems with the 3V, or you may not. Batteries vary widely in manufacturing specifications. Why, I don't know. I would assume that batteries would be one of those commodity items that there would be some control in manufacturing, but obviously there is not. The other factor that you can say about the batteries is these have this transparent cover on them, which amounts to heat shrink tubing. This is extremely thin plastic material on these batteries. Now, if you use a thicker plastic material for your heat shrink tubing, you've just changed the diameter of what you're going to stuff into your battery tube. The battery itself may not be any larger, but the thickness of the plastic over it is. Now, it is not a fix to remove that plastic. It doesn't make any difference for the bottom battery because the outside is the negative terminal that's going to be connected to the outside here. The difference it makes is this one here. This one is going to be sitting on top of this battery, so it's going to be 3.7 volts higher than this, the battery tube. In effect, what you'll do is you'll short out that bottom battery. SVR has blowout, safety blowout on the bottom of the tube. So does the 3V. So does the Evo, I assume. I have not taken any time to get in contact with, I believe his name is Dennis in New York, who has the Evo for sale. But coming from Loom Totem, I assume these are all of similar manufacture. It does not make any sense to manufacture these things any differently. So there you have it. Controversy settled. The SVR and the 3V are temperature controlled mods. The temperature control is not an extremely tight temperature control, but it's going in the right direction. Are you going to see refinements on this device? You bet. You are going to see lots of refinements on this device. And when you really stop and think about it, what you want out of something like this is you want something that is going to give you a constant temperature. So when you're vaping this stuff here, it's baking at the same temperature every single time. Variable voltage doesn't do it. Regulated voltage doesn't do it. You hold regulated voltage down, the atty coil stays hot, it keeps getting hotter. You cut it off automatically, you do some sort of temperature control, and you are keeping, or at least the goal is to keep that coil at the same temperature. Now, comments have been out there. I've seen them. You've seen them. The comments are, this gives an incredibly consistent vape. It does. It's amazing to me that they got as much as they got into this little module right here. And they did. I've had one of them open. It's a single circuit board, double-sided components, highly miniaturized. It is not one of your simple little fake-it-out circuits. It doesn't have any sort of mechanical thermostat in there. This thing is totally electronic, and it's fairly well built. So if you want it, buy it. Make up your own mind. But that's the way it is. They're basically the same product. You guys have a good day.